Hello. This lesson is on homework 8.5, which is about factoring shortcuts or factoring special cases. The factoring shortcuts, if you recognize them, will make things a little easier for you. We'll learn about two of them today. One is called a difference of squares, and the other one is called perfect square trinomials. Here's how they work. To recognize that you have a difference of squares, it means literally what it says. You have a difference because there's a minus in the middle, and you have squares, a squared and b squared. And when we factor it, you end up with two binomials multiplied together. One has a plus in the middle, the other has a minus, and you take a and b, meaning the square root of this and the square root of this, because a is the square root of a squared. B is the square root of b squared. Let's look at some examples. So if I want to factor 9y squared minus 4, is this a perfect square? Is this a difference of squares? And it is, because 9y squared is a perfect square. The square root of it is 3y. 4 is a perfect square because its square root is 2. So to factor this, we get 3y plus 2 times 3y minus 2, because 3y is the square root of this, and 2 is the square root of this. So we just repeat these numbers and put a plus inside one binomial and a minus in the other. These next three examples, x squared minus 121, they are both perfect squares. So we end up with x plus 11 times x minus 11. Number 2, we have a perfect square 9y squared. We have a perfect square here, 169 x squared. The square root of 169 is 13, so we end up with 3y minus 13x times 3y plus 13x. Please note, it does not matter if you put the minus first and the plus second, or vice versa. That makes no difference. What does make a difference is the original binomial that you're factoring must have a minus sign in it. It is a difference of squares. Example 3, x to the fourth is a perfect square, as is 16. So when we factor this, we get x squared minus 4 times x squared plus 4. However, you may notice that x squared minus 4 is itself a difference of squares, because we have a perfect square of x squared and a perfect square of 4 with a minus sign in the middle. So this binomial also you can factor using the difference of squares rule. So you end up with x minus 2 times x plus 2 times x squared plus 4, because the x squared minus 4 factors into x minus 2 times x plus 2. Moving on to the next factoring shortcut. We have what are called perfect square trinomials. They can look like a squared plus 2ab plus b squared, or they can look like a squared minus 2ab plus b squared. And we call them perfect square trinomials because when you factor them, the two binomials are the same. So in other words, it is a binomial times itself, or a binomial squared. So you just have to recognize when you can use this shortcut. And when you do recognize it, it becomes very easy. So what you do is you notice if the first term is a perfect square and the last term must be a perfect square. If they are, then you take the square root of the first term and the square root of the second term and multiply them together. So in this case, the square root of the first term would be a. The square root of the last term would be b. Multiply them together, you get ab. Then double that. That would be 2ab. If that equals the middle term, then it's a perfect square trinomial. In which case, when you factor it, all you need to do is put the square root of the first term here, the square root of a squared, and the square root of the last term, b squared, here, and then make it a binomial squared. The same exact thing applies for this version, except that you have a negative sign and a minus sign and a plus sign in the original trinomial. Now you can factor a perfect square trinomial just like you factor any other trinomial. But if you recognize that it's a perfect square, it's a little faster, so you don't have to engage the guess and check method. So for example, let's factor this trinomial. We could use guess and check, but we don't need to, because we can see that x squared is a perfect square. We can see that 16 is a perfect square. And when we square root x squared and we square root 16, we get x times 4. And then if you double that, you get 8x, which is the middle term. So that means that we can factor this trinomial just by putting the square root of x squared plus the square root of 16 and then square it. So we get x plus 4 squared, because x is the square root of x squared and 4 is the square root of 16. Let's try one with the minus sign in it. And just a reminder, always check for a GCF first. In this case, there is no GCF, but you should always look for one anyway. 4x squared is a perfect square. It's 2x squared. 9, of course, is a perfect square because it is 3 squared. So let's take the square roots of both of those, and we get 2x times 3. Then double that. What do we end up with? 12x, because 2 times 2 times 3 is 12, times x is 12x, which is the middle term. So we do have a perfect square trinomial. So that means our answer, our factored form, will just be 2x, and then we're going to put minus 3, and then parentheses around all of that, and square it. So 2x minus 3 squared, because 2x is the square root of 4x squared, 3 is the square root of 9, and then we square that entire quantity. Okay, if you have any questions on this, send me a message on Remind, or attend the Zoom meetings on Tuesday and or Thursday. And I hope you're doing well, and take care of yourself. Bye for now.